All right, part 3. We are going to do a nice review of graphing the natural exponential function. Part 1, we already did the logarithmic function. So let's talk about this in terms of our definition of how exponentials and logarithms relate. We learned in the first video that the natural log of x is equal to b if and only if, when you take that base and you do the swing around, e to the b is equal to x. So what's happening there connects with our second video in the concept that exponentials and logarithms, when they have the same base, are inverses of each other, which means that if I were to undo an exponential, I would want to take a log with the same base of both sides. Well, because this is the log of an exponential with the same base, these cancel out, and b is equal to the natural log of x. So it's kind of a circular definition for how these things relate to one another, but we're going to use the idea of inverses to help us graph e to the x. So x, e to the x, -1, 0, 1, 2, 3. Well, I know anything to the 0 power is going to be 1. I know that e to the first power will be 2.718. And now I'm going to jump to my calculator to get the other values. So here's our y equals. No longer interested in natural log. I want its inverse, which is e to the x. I'm going to graph that one. And then I'm going to use my table feature. And if your table didn't save from last time, you can use this to type in, or you might have the auto-generated table, which is fine. So 0.368 and 7.389. And finally 20.086. Gets really big really fast because exponential growth, is a thing. So graphing this, I have -1.368. I have the 0.01. I have the 0.1 e. I have the 0.2, 1, 2, 3, 7, and a little bit more. And then the other one is going to literally be off the chart. So I'm going to go ahead and graph this in the shape of an exponential. Some things to note. Our key features on the natural log graph were x equals 0 for the vertical asymptote. Here we have a horizontal asymptote of y equals 0. On the original natural log graph, we went through the point 1, 0. Here we go through the point 0, 1. And on the original natural log graph, we went through the point E1. Now we go through the point 1, comma, E. So those will be our 3 key features when talking about the exponential. Because they are inverses of each other, the domain and range switch. So again, on the natural log graph, we had x equals 0, the point 1, comma 0, and the point e, comma 1, both exponentials. We're finding the inverse, so we are switching those things around. All right, properties of the natural exponential function. The domain this time is going to be, I'll keep it consistent with video 1, all real numbers, which would be -infinity to infinity. And this time our range is that y has to be greater than 0, so 0 to infinity. Again, notice that's switching, interchanging the domain and range from our natural log function. Sorry, brain pause right there. The function is continuous, which means we can draw without picking up our pencil, well defined for calculus purposes. The function is increasing still, which means that the derivative will always be positive. And there's that 1-to-1 thing. So 1-to-1 is for every y value in the range, there is one corresponding x value in the domain. And in our case, this graph is always concave up. If we think real quick about the natural log graph from the first video, it looked like this, and our exponential graph looks like this. There is a reflection over the line y equals x because all you're doing is switching out your domain values and your range values. There's your summary of exponential.